The final question is on discrete random variables, and we are here presented with a situation where we've got a fair dice which has faces numbered 1, 1, 3, 3, 5 and 5, and we're told that the random variable b represents the score when the blue die is rolled. And the first thing we're asked to do then is write down the probability distribution for b. So in our probability distribution table here, we've got the particular value b. So b can either be 1, 3 or 5, so that's what we've got here, and then we need to figure out the probability that each of those occurs. So there's two ways you can get 1, 6 in total, so the probability is going to be a third, and as you can see that's going to be the same for all of those. So that's all we need to do for part A. For part B then, you will notice that there are only 3 things that can happen, and each of these have exactly the same probability. So the name of this probability distribution is the discrete uniform distribution, because the probabilities are all the same or uniform. Part C, then write down the value of EB. So this is the expected value. And remember that to find the expected value, or the mean you might hear it referred to as, we're just going to take each of the outcomes. So in the first instance, the outcome here is 1. So we're going to take 1 and multiply it by the probability that it occurs. And then we're going to add 3 multiplied by the probability that it occurs. And finally, 5 multiplied by the probability that it occurs. If we add that all up, we should see that we get a value for B, the expected value of B, of 3. However, you might notice that just by looking at the distribution here, by symmetry, we can see that the expected value would be 3 as well. In part D, however, we can see that we've actually got different probabilities. So we've got a second die. So the second die is red, and the random variable R represents the score when the red die is rolled. And we've been provided in this table with a probability distribution for R, and we can note, as I said earlier, that the probabilities here are different. So in order to work out the expected probability of R, we can't use symmetry. We're actually going to have to use the formula again. So this time the expected value of R is going to be the first outcome, which is 2, multiplied by the probability of it occurring. And to that we're going to add the second output, 4 multiplied by the probability of it occurring. And the third output multiplied by the probability of it occurring. And if we do all that and sum it together, we should find that the expected value for R is also 3. Part E then, find the variance of R. So the formula for the variance, we can either look at the formula sheet, or remember that the formula for the variance is going to be the expected value of R squared minus the expected value of R all squared. Now you can see up here we've already got the expected value of R, so this bit's basically done. We essentially here have got to work out what ER squared is. So if we work out the expected value of R squared, it's going to be in exactly the same way, but let's just put in another column here for R squared. So this is going to be 4, this is going to be 16, and this is going to be 36. So we're now going to go through and do exactly the same thing. The first outcome we're looking at here for R squared is 4. So we're going to do 4 multiplied by the probability it occurs, which is 2/3. And we're going to add the second value, which is 16, multiplied by the probability that it occurs. And finally, 36 multiplied by the probability it occurs, which is 1/6. So if we add that all up, we should get a value for E of R squared of 34/3. So if we go back to this formula here, we can say that that's going to be 34/3 minus 3 squared, and that should give us an answer of 7/3. In the final question, then, we're looking at the probability that Avicii wins the game. So the game involves Tom spinning a coin with one side labelled 2 and the other side is labelled 5. So if we have a look at the tree diagram here, that's what we've got here. He's going to toss a coin that can either land 2 or 5. And then we're told that when Avicii shows the number, when she sees the number showing on the coin, she then chooses one of the dice and rolls it. If the number showing on the die is greater than the number showing on the coin, Avicii wins, otherwise Tom wins. And we know that Avicii chooses the die which gives her the best chance of winning each time Tom spins the coin. So in the first instance then we've got this is Tom spinning the coin. And we've got here the distributions from the blue dice and the red dice to figure out what's actually happening here. So in the first instance, if a 2 has been flipped on the coin, so Tom's tossed the coin and he's got a 2. What Avicii wants to do then is choose a dice which gives her the best chance of winning. So she's got to try and get a score greater than a 2 on the dice. If she chooses the blue dice, the chance of her winning, she wants a number greater than a 2, so she can either get a 3 or a 5. So we need to add these two together. So the probability of her winning if she chooses the blue will therefore be 2/3. If she chose the red dice, the probability of her winning, well, it could be either of these, but if we add a 6 and a 6, we're only going to get 1/3, which is a lower probability. And we know that in each game, she would choose the dice which gives her the best chance of winning. So we're going to be interested in this route here. So if she spins, if the coin is a 2, she is going to choose the blue dice. If, however, the coin is flipped and we get a 5, she's going to try and score greater than 5 on the dice. So she has to choose the score that maximizes her chances of getting greater than a 5. And we can see that from the blue dice, the largest score that you can get is 5. So she's got 0 chance of getting a score greater than 5 if she chooses the blue dice. So therefore she's going to choose the red dice and we can work out the probability that she wins. The probability that she wins is going to be just this one here, 1/6. The question asks us to state clearly what she should do in both instances. So we can see then if the dice is 2, she should choose the blue dice. If the coin is 5, she should choose the red dice. The probability that she wins the game then will be half times her winning on the blue dice. So that'll be a half times 2/3. So a half times 2/3. And to that, then, we need to also add the probability that the coin is flipped and she gets a 5, and she wins on the red dice, which is going to be a 6. So we're going to add a half times a 6, and if we work that all out, we should get an answer of 5/12.